Welcome in the next chapter of the logic operation in practical usage. In this chapter I would like to familiarize you with some of word logic operations. As you can see in the instruction, we have got this in a word logic operation folder, and exactly here we have got the most important functions, blocks. It is AND operation, OR, and exclusive OR. We can use these blocks as normal logic operations as logic functions. If you know how it works exactly, AND operation, OR operation, or exclusive OR operation. How is the main difference? AND operation, if we have got here 1 and 1 on each of the input, then we have got on the output 1. If we have another situation, the output will be always 0. The operation of the block OR is similar, but work a little bit another. It looks like when we have got here 0 and 0, then on the output will be 0. All other situation will be 1. And the exclusive OR, it is some special function, and it works in this situation. If we have got here 1 on first input and 0 on second input, or in another way, so 0 on first input and 1 in second input, then our output will be 1. So always different signals here. If we have got here 0 or 0 0 or 1 1, then we have always on the output 0. We can use this function as normal logic function, but it's not our task today in our course. We want to use this function as the masks. Mask. It is a good question. What does it mean exactly? The mask is something like this, that we can control some byte, because for example we can choose here that we want control byte, word, double word. As you remember the differences between these declarations. So byte, it is 8 bits. So for example 8 devices. Each device has own position according to the binary system, and it should be always on the first position, our controlled byte. In second input we should use our mask, which will have some special impact on our counting, because on the output will be the same what we have got on input 1, so our devices. And this mask will do something, and will be working differently for each function. How it will be exactly, I will show you now in the Excel. I prepare in Excel some tables in order to better understand these functions. So start with the first function, the function AND. As I told you, if I have on input 1 and input second 0, the result is 0. The result is 1 only if these two inputs in the same time has the value 1 or the value true. And how it looks like using the mask. Here we have got our byte, so byte has 1, 2, 3, 4, 5, 6, 7, 8 bits, as I told before. And here we have got our mask. So our byte, it is our input 1 in our block of AND, and mask is input second on our block. The result is our output, so the result will be also our byte after some operations. But about this I tell you later. And how it looks like, for what we can use this mask. As you can see, if we have some device switched on, because we can say that each bit in our byte has some description that this bit controls some device. So for example, here is our lamp, here is our second lamp, here is our motor, here is our speaker, our computer, and so on. Our first device has the state 1. When we give here mask 1, so after this operation 1 and 1, it gives exactly 1. In other situation, if we put here 0 in our mask, so we can see that always when we have got 0, for example here, in these two situations, our output will be always 0. So what we make by using this state? We can see the first situation. If our byte was 0, we give mask 1, so it is 0. So our block end with using the mask is for this, that we can, by using mask equal to 1, we copy the state of the device. If the device was switched on, then after this operation is switched on. So we do not on any operation on this device. The same if was switched off, stay switched off. But if we put 0, then we want our device to be switched off. We do not care about this, that this device was switched on or switched off. We want to be sure that our device after this operation will be switched off. So this mask is for switching off devices on bit described by our mask. Second will be now easier because it is function or working analogously to our AND operation. As we can see, if we have got 2 zeros, output will be 0. If we have got 1, it will be set to the 1. So we can see once again our byte the same and the same mask, but the result is different. What we making now? If we have got our mask 1, as you can see here, then we have got exactly the one from the output, yes? We switch on our device. If we have 0, we put mask 1, we have got our result 1. So there, when we put in our mask 1, we want to be sure that our device will be switched on. So the mask OR is for switching devices. The mask AND is for switching off devices. When we put 0, our state is copied from previous state. So when we put in the mask 0, our byte was in this place 1, it is 1. If was 0, we put 0, is exactly 0. And the third function, a little bit more complicated, but I think in my case and after many applications, it is the most often used, this function. Why? You see that if we have got different states, so these middle two columns, our output will be 1. If we have the same state, our output will be 0. So how it can be used? We can once again check our byte. Once again the same byte and the same mask, but the result is different. What we can see here now, there where we put 1 in our mask, our device is switching to opposite state. So if our byte in this place, so this bit was 1, it is switched to 0 because we have got here 1 in our mask. If was 0, our mask in this place is 1, will be switched on. So there where we put 1 to our mask, our device will change state. If was switch off, then will be switched on. If was switch on, there will be switched on. So a little bit complicated in understanding, but I think that you haven't got any problem with it. And last thing, we have got 0 also in mask, so the 0 does not change the state of the device. So we put only the information in the mask about the devices which we want to change the state of these devices. But we don't exactly control the state to switch on, to switch off. We only want to change the state. We don't know exactly if this device will be, after this operation, switch on or switch off. We know only about this, that this device will change the state. So now come back to the program and start programming.